Imagine a world where compasses point south instead of north, where the Earth's magnetic field flips, rewriting the invisible lines that guide everything from migrating birds to our planet's defense against cosmic radiation. This isn't science fiction. It's a real phenomenon called magnetic pole reversal, and Earth's ancient rocks hold the secrets to this incredible process. Today, we're diving into the science of magnetic pole reversals, exploring how they happen, why they matter, and what Earth's hidden record tells us about our planet's dynamic history. Let's start with the basics. Earth's magnetic field is like a giant shield, generated deep within the planet by the movement of molten iron and nickel in its outer core. This field stretches far into space, protecting us from harmful solar and cosmic rays. But it's not static. Over millions of years, the magnetic poles, the north and south magnetic poles, can swap places in a process called a geomagnetic reversal. During a reversal, the magnetic north pole becomes the south pole and vice versa. It's not an instant flip. It can take thousands of years, with the magnetic field weakening, shifting, and sometimes even becoming chaotic before settling into its new configuration. So, how do we know this happens? The evidence lies in Earth's ancient rocks, particularly those formed from molten lava. When lava cools and solidifies, tiny magnetic minerals like magnetite act like miniature compasses. As the lava hardens, these minerals align with Earth's magnetic field at that time, locking in a snapshot of its direction. Scientists call this Paleomagnetism. By studying rocks of different ages from around the world, researchers have pieced together a timeline of magnetic reversals stretching back hundreds of millions of years. This is Earth's hidden record, a geological archive written in stone. One of the most fascinating discoveries is that magnetic reversals happen irregularly. Over the past 83 million years, the Earth has experienced reversals on average every 200,000 to 300,000 years, though the intervals can vary widely. Some periods, called supercrons, lasted tens of millions of years without a single reversal, while others saw flips every few tens of thousands of years. The last reversal, called the Brunhes-Matuyama reversal, occurred about 780,000 years ago. That means we're technically overdue for another one, but don't worry, the process is slow, and there's no evidence it's happening right now. What causes these reversals? The answer lies deep in Earth's core. The outer core is a swirling ocean of molten metal, driven by heat from the planet's interior and Earth's rotation. This movement creates electric currents, which in turn generate the magnetic field, a process called the geodynamo. But the geodynamo isn't perfectly stable. Complex fluid motions in the core can disrupt the field, causing it to weaken and occasionally flip. Computer models suggest that these reversals start with patches of reversed magnetic flux at the core mantle boundary, which can grow and eventually dominate, triggering a full pole reversal. It's a bit like a cosmic dance, with the Earth's core choreography deciding when the poles take a new lead. Now, you might be wondering, what happens during a reversal? Does it cause mass extinctions or global catastrophes? The short answer is, probably not. Scientists have found no consistent link between magnetic reversals and mass extinctions in the fossil record. However, a weakened magnetic field during the transition could let more cosmic radiation reach Earth's surface. This might stress ecosystems or slightly increase mutation rates in DNA, but there's no evidence of widespread devastation. Ancient human ancestors lived through the last reversal, and life on Earth has persisted through hundreds of them. Still, a reversal could have practical impacts today. Our modern world relies heavily on the magnetic field. Satellites, power grids, and communication systems could face challenges if the field weakens significantly. During a reversal, the magnetic field doesn't disappear entirely, but it can drop to about 10% of its normal strength and become more complex, with multiple magnetic poles forming temporarily. This could disrupt technologies that depend on a stable magnetic field, like GPS or compass-based navigation. Thankfully, any reversal would unfold over thousands of years, giving us time to adapt. Earth's hidden record also reveals something profound. Our planet is dynamic, constantly changing in ways we're only beginning to understand. By studying paleomagnetism, scientists have mapped out the history of plate tectonics, as the magnetic signatures in rocks help reconstruct how continents have drifted over time. For example, rocks in North America and Europe show synchronized patterns of magnetic reversals, confirming that these continents were once joined in a supercontinent called Pangaea. This connection between magnetic reversals and plate tectonics is like a cosmic jigsaw puzzle, with each rock providing a piece of Earth's history. Another intriguing clue comes from the ocean floor. As new crust forms at mid-ocean ridges, it records the magnetic field's orientation, creating symmetrical stripes of normal and reversed polarity on either side of the ridge. These stripes, discovered in the mid-20th century, were key to proving plate tectonics and remain one of the most stunning visual records of magnetic reversals. Imagine the ocean floor as a giant tape recorder, preserving the rhythm of Earth's magnetic flips over millions of years. So, what does the future hold? Predicting when the next reversal will occur is tricky. The magnetic field has been weakening slightly over the past few centuries, but this could just be a temporary fluctuation. Scientists monitor the field using satellites and ground-based observatories, looking for signs of an impending reversal. For now, there's no cause for alarm, but the possibility reminds us how dynamic our planet is. Magnetic pole reversals are a testament to Earth's restless nature. They show us a world in constant flux, where even something as fundamental as the magnetic field can turn upside down. By reading the ancient record locked in rocks, we uncover not just the history of these reversals, but a deeper understanding of our planet's inner workings. From the molten core to the ocean floor, Earth's magnetic story is one of change, resilience, and mystery, a story written in stone, waiting for us to decode its next chapter.